Hello, my name is Ahmad Ikhwan Afiq and I'm going to talk about my final year project titled A Review on Synthesis of Zeolite from Rice Husks and Aluminium Foil from Soil Gel Method. Zeolite is an adaptable molecule that comes under the family of fungicide. Zeolite has a 3D structure that is porous and acidic. Zeolite constitutes an essential category of material capable of performing a range of essential functions including ion exchange, absorbance, and catalyst. Rice husks were selected to synthesize zeolite, while rice husk has a high perspective for zeolite because of their high silica content, and alumina is another competitor for zeolite synthesis because in this work aluminium foil was used as an alumina source because it has a reasonably low cost and a high purity. Rice husk is an agricultural byproduct abundantly available in rice producing countries like Malaysia. Much of the rice husk produced from the processing of rice is either burnt or dumped as waste. Burning of rice husks contribute to the greenhouse gases being released and can be a health hazard. Many research involve utilizing rice husks as it is high in silica content and may reduce pollution caused by it. Aluminium foil can also be recycled as a raw material for the zeolite synthesis. These are the objectives of study and significance of study proposed for this thesis, and the 5 research questions are created based on the literature review. Zeolite is a natural or manufactured mineral with a distinct crystalline structure. Tetrahedral alumina and silica are the primary structure of zeolite as shown in the figure. Natural zeolites are mostly volcanic in origin and are hydrothermal. They can be found in crystalline form in igneous and metamorphic rock as well as in sedimentary rock grain of lower dimension. Synthetic zeolites are different types including zeolite Y, zeolite X, zeolite A, and zeolite P are some of the examples. The difference between these zeolites are due to the aluminum content which they are synthesized, which not only the alumina content affects not only the crystal structure but also the ion exchange sensitivity of the zeolites. Rice husks contain many elements as presented in the table. As you can see in the table, the silica content is more than 60%. The silica content of the rice husk may depend from the variety of paddy, but the value is mostly 15%. Therefore, it is available to use rice husk as a silica source. Silica can be pyrolyzed at raised temperature to form rice husk ash, or it can be extracted from rice husk in the form of sodium silicate by using a solvent extraction method. Alumina is another constituent used for the synthesis of zeolite. Aluminium nitrate, aluminium sulfate, and sodium alumina are the common source of alumina. Aluminium foil was used as alumina basis since it is simple to get at a reasonably low cost and high purity. Alumina is extracted using solvent extracted method. Small pieces of alumina foil is mixed with sodium hydroxide to produce the alumina precursor. The soil gel process involves the transition from the liquid soil to a solid solvent phase. The technology that eventually delivers greater absorbency and particular element size is better controlled by this method. There are factors which can influence the performance of this method. There are hydrolysis rate, temperature, heating, and pH. The table shows the advantage and the limitation of the soil gel method. Although it has a lot of advantages, it also has its limitation, the soil gel method. For the characterization of the zeolite can be evaluated by using FTIR for the functionality, using SRD for the structure, and scanning using SEM for the microstructure. The structure and the properties of the synthetic zeolite vary greatly. The crystallization of different types of zeolites is affected by factors such as reaction duration, temperature, pressure, and the chemical composition of the reaction mixture. The FTIR analysis method uses infrared light to scan test samples and observe chemical properties and used to identify organic polymeric materials in the zeolite. The FTIR spectra of the zeolite are basically similar regardless of the AI source, as in the example beside. X-ray diffraction analysis, or SRD, is used to determine the crystallographic structure of a material. SRD analysis is to allow identification of the crystalline phase present in the zeolite material. The gradual growth of the crystalline phase can be affected by increase of the calcination temperature, and the crystalline phase also change based on the AI source, alumina source, or the composition of the zeolite. The surface morphology, including the shape of particles and pattern of distribution, are revealed using scanning electron microscopy, or SEM. A study conducted by Padiangan to assess the influence of calcination temperature on microstructure, micrograph of 3 zeolite samples at 100% magnification in figure 1. And another study by Sima Junta comparing SEM of the samples against a commercial zeolite and shows the difference between crystallization time can have on the surface structure of the produced zeolite in figure 2. In conclusion, aluminium foil and rice husk can be used to synthesize zeolite. Both has a high content for silica and alumina respectively. The extraction process for both materials are the same, using solvent extraction method. The precursor is mixed to produce a gel and dried for at least 24 hours. The solid is then calcinated around 600 degrees Celsius for 2 hours to transform it into a zeolite. The characterization of the zeolite produced can be done using FTIR, SRD, and SEM. And the soldier method is versatile and do not need the use of any specific equipment. And for the recommendation, this review focuses on the synthesis of zeolite from rice husk and aluminium foil by soldier method. Although there are many journals utilizing rice husk for synthesizing zeolite, there are few by using the soldier method, which has potential for commercial as it is a simpler process than most other methods. It is suggested researchers conduct additional research on synthesis by soldier method, as there are so few comparing to other methods of synthesis.